Hi, my name is George Pulinattu. In this video, I will demonstrate how to set up monitoring for your Mongo database servers using Icinga. For this demonstration, we already have a Mongo replica set. This replica set has 3 nodes. Mongo node 1 is our primary. The other 2 are our secondaries. Also, we have our Icinga server set up and configured as master. Please refer to my previous videos to learn how to install and set up Icinga and configure it as your master server. I have already connected to my Mongo database servers as root user. Also, I have connected to my Icinga master server as root. Let's do a systemctl status Icinga2 and check the status of our Icinga2 master. Now, let us open the Icinga web console in a web browser. As you can see, I already have 2 hosts monitored. One is Icinga server itself and another is a test client that I added to see if everything is working properly. Let me get back to my Mongo node 1 and show my Mongo database replication setup. We switch the user to MongoDB. Then type Mongo to get into Mongo command line interface. Here we type rs.status. This will give us the status of our replica set. Let me scroll up a little bit. Here you can see Mongo node 1 is my primary. Then Mongo node 2 and Mongo node 3 are my secondary. Let's exit from here and give you an overview of the steps that we will be following. First, we will install Icinga2 on all the 3 nodes of our Mongo database replica set. Then we will install Nagios plugins on all the 3 nodes. Also, we will install check_mongodb.py script. This script is available to download from GitHub. This is a Python script and we need to install PyMongo, which is a Python driver from MongoDB. Next, we will initiate Icinga node wizard from each node and configure them as clients. First, we will define group. Similar servers are assigned to a group. For example, all the Mongo database servers that are running on Linux can be classified under the group called Mongo in Linux. Another example would be all the Oracle servers that are running on Linux can be classified under group called Oracle on Linux. Then we define endpoint, zone and client, which are how Icinga master sees client. More about it will be explained in next slides. Then we assign services that are monitored. To each client, we define group in a config file called groups.conf. We define a host group, Linux-servers-Mongo. Then we give it a display name. This is how this group will be displayed in Icinga web console. Then the important part is where we tell to assign this group to all servers with vars.os. Set as Mongo in Linux. Next we will configure client in a client.conf file, where client is typically the fully qualified name of the host that you are monitoring. For training purposes and to understand how things are linked to each other, I have defined endpoint and zone in the same file itself. Also note that I defined separate zone for each client. For a production setup with satellites, a bunch of clients comes under one zone. For example, you can define a zone Chicago or Denver, and Chicago zone has bunch of clients and Denver has bunch of clients or endpoints. In the host section, we have to have check _ command. This is typically set as host alive check, that the address of the client, the fully qualified domain name or IP address of the client, the parameter vars.endpoint is defined as name. This tells that endpoint is the name of this client itself, so it is important that the name you given to this host matches the endpoint definition. Also, we set vars.os as Mongo in Linux. This group was defined earlier in groups.conf file. Now, we define what all services that we will be monitoring in services.conf file. In this example we tell to apply service Mongo connection to all the hosts that are endpoints and vars.os parameter set as Mongo in Linux. By default, MongoDB command checks connectivity to MongoDB. More commands can be found in the link provided in the description of this video. The most important parameter is a command under bar endpoint. This tells Icinga where to execute this command. In this case, commands will be executed at the clients we defined in the clients.conf.
Now, let's start the installation process. First, make sure the firewall is stopped by issuing systemctl status firewall and hit enter. Do the same thing on all the 3 nodes of Mongo replica set. If you decide not to disable the firewall, you will have to open the port 5665 on your firewall, so client and master can communicate. Then we will install the EPEL repository, which will take a couple of seconds. After that, we will install the Icinga repository. Link to these are found in the install instruction pages given in the description of this video. These repositories are installed on rest of the nodes. I will fast forward those steps. Now we will install Nagios plugins first. This is done by command yum install nagios-plugins-all. While Nagios plugin install is running on node 1, we will initiate the installs on nodes 2 and 3. Yum will resolve all the dependencies, then download them, then install and validate them. This will take a couple of minutes, and this depends on how fast your internet connection and servers are. Now, type yum install Icinga2 and hit enter. This will start installing Icinga2. This will also resolve dependencies, download packages and then install and validate them. Once installation on node 1 is completed, proceed with installing Icinga2 on node 2 and 3. Those also takes couple of minutes. At this point we have Nagios plugins and Icinga2 installed on all the 3 nodes of our MongoDB replica set. Now, we run the command systemctl enable Icinga2. This is to ensure that Icinga2 daemon starts at the time of system reboot. We do this on all the other 2 nodes, Mongo node 2 and Mongo node 3. Now, we will start Icinga2 services by using command systemctl start Icinga2. We do this on all the other 2 nodes, Mongo node 2 and Mongo node 3. At this point Icinga services should be up and running on all the 3 nodes. We will check this by running command systemctl status Icinga2. On Mongo node 1 everything looks good. Now we check the status on Mongo node 2. Once validated we check the status on Mongo node 3. We are almost done with installations. Navigate to Nagios plugins directory. We will download check MongoDB.py script from GitHub. The path to the script is as shown in the screen. Or you can Google check mongo.py and you will find the script. Now, using chmod, make the check mongo.py script executable. Now, for check mongo.py script to connect to Mongo database we need to install Python driver for Mongo called pymongo. First we download the zip file from GitHub. Then unzip the master.zip. Then cd to mongo-python-driver-master directory. Under that directory there is a script called setup.py, we will execute that. To do that, we run the command python space setup.py and then pass in the flag install, then hit enter. Once we finish installing this on node 1, we will proceed the installation on Mongo node 2 and Mongo node 3. I will fast forward this part, as it is identical to the steps we followed on Mongo node 1. To recap, At this point we have Icinga2, Nagios plugins, check Mongo script and all the necessary drivers installed on all the 3 nodes of the MongoDB replica set that we are going to monitor. Now, we will start the configuration steps. Our first step is to configure Icinga as client. To do that, initiate Icinga node wizard. Type Icinga2 space node space wizard and hit enter. It will ask if this is a satellite or master setup. Type Y and hit enter, as this is a client. For common name we give the fully qualified domain name of the client. In our case this is mongonode1.gsp.com. Next, it will ask for the common name of your master. This should be same as when you set up Icinga2 master. Typically this should be the fully qualified domain name of your master. In our case this will be icingaserve1.gsp.com. Here, type Y and hit enter to establish connection between master and client. It will ask for your master's IP address or FQDN. It's strongly recommended to give FQDN, which is fully qualified domain name. Endpoint port is 5665. And we don't need to add more master, so type N and hit enter. CSR auto signing is required to establish encrypted connection between master and client. We give the FQDN of master and the port where Icinga is listening, which is 5665. Once we verify the certificate information, type Y and hit enter. Now, we have to generate Pki Ticket from the master for this specific client and provide it here. The hint will tell you what exactly to do. Just copy and paste the generated ticket from master to the client. For bind host and bind port we leave empty. It's important that we accept config and commands from master. So, type Y for those two. With this node wizard is done. To complete we just need to restart the Icinga2 daemon at client then master. To do that, type systemctl restart Icinga2. Now, we will start the Icinga2 node wizard on the other 2 nodes, Mongo node 2 and Mongo node 3, and configure them as clients. The configuration process is exactly identical to what we just did. So I will fast forward that part. I strongly recommend to visit the web link given in description of this video for detailed and updated instructions. Once we finish restarting Icinga2 on node 2 and node 3, we are all set to start our final configurations. Before proceeding further, let's check a couple of things. In our zones.conf filing clients, if everything is done correctly, you will see 2 endpoint definitions, one for master and another for client. Node name means it will just substitute FQDN of client. Also 2 zones, one for master and another for client. Also note that in client's zone name there is a parameter parent. This has to be set to Icingaserve1's zone, in our case it's master. We will append the following lines to the zones.conf file. This is a global template zone, with parameter global set as true. This is done for syncing check commands later. Now we have to make sure that accept commands and accept config parameters are set as true, in a pi.conf file. Now run the command icinga2 space daemon space -c. This will check for any errors in your configuration files. Then we will restart Icinga daemon command systemctl restart Icinga2. This is done on all the nodes and also on your master. At this point, if you check in your Icinga web console, you will not see the nodes there. This is because we still need to configure the clients at the master. First, we will define a group in groups.conf file in the Icinga master server. We will define a group Linux-servers-Mongo. This will have a display name Mongo servers. This is how this group is displayed in Icinga web console. Also we have an assignment rule which says, assign this group to all clients which has vars.os set as Mongo on Linux. Now we navigate to master directory, located under zones.d. This is where we will create our client configuration files. It is recommended to create configuration file in the format fully qualified domain name of client.conf. First we will define an endpoint for the client. Note that endpoint name is the fully qualified domain name. Also with host parameter we tell which client this endpoint is pointing to. Next we define a zone for this client. Endpoint is what we just defined and parent is set as master. Now, we will define host. It's recommended to give FQDN as host name. Host definition should have check command parameter. We will set it to do a host live check. The address parameter can be either IP address or fully qualified domain name. I prefer FQDN. Then we need to define vars.client_endpoint. We set this as name. This tells Icinga that host name is the endpoint name. Then we will set vars.os parameter as Mongo on Linux. Remember that we defined this group earlier in groups.conf file. Now we create similar definitions for Mongo Node 2 and Mongo Node 3. For this I am just going to copy my Mongo Node 1 config file and edit the contents. Let's recapture what we have done so far. We have defined group Mongo on Linux on groups.conf file, then we have defined clients in client.conf file. Each client will have its own configuration file. Now we will configure services to monitor. For that we open our services.conf file. At this point we have some basic Linux checks like CPU, load, disk usage and swap space usage. Give special attention to assign clause. Right now it just tells to run this check commands on all the endpoints, in our case clients. We will now tell it to run these checks on all the endpoints which belong to either Linux or Mongo on Linux group. To do that, we append the following line, ampersand, then open bracket host.vars.os equals Linux, or host.vars.os equals Mongo on Linux. Then we close the bracket. We append this to end of each assigned statement. Then we save and close the services.conf file. Now we run Icinga2 space daemon space -c to check if all our syntaxes are correct. Everything looks good. So we issue the command systemctl restart Icinga2. This will restart Icinga2 daemon. Now when we check our Icinga web console we can see the three newly added servers, Mongo Node 1, Mongo Node 2 and Mongo Node 3, not that the status shows pending, as the checks haven't run yet. I am now manually forcing the checks to run by clicking Check Now button. If you click on the Host Groups tab, you will see different host groups that we configured. You can see our group Mongo servers appear here. Looks like some servers are still in pending state. I will force the check now. Now we will navigate to host groups, then click on Mongo servers group, then Mongo Node 1. You can see 7 services are monitored and everything looks good. Now we will configure Mongo specific services. To do that, get back on our command window and open services.conf file in an editor. The Mongo specific check commands and formats are given in my website. The link to that is given in the description of this video. Just copy and paste those from that website to this services.conf file. What each check does is beyond the scope of this video. I will let you read about that in the plugin documentation. I will save and close this file. As usual we check for syntax errors by issuing command Icinga daemon -c. Then systemctl restart Icinga2. Now when we look at our web console we can see those new services here. They will be in pending state. If we wait some time it will run the checks on its own. But, due to time limitations I will force the checks to run now. Looks like all our checks are in OK state. Before we end this video, let me show you something. Click on the Services tab, then in the search, type *replica set*. It will filter my MongoDB replica set related checks. You can see that, It automatically detects if a node is primary or secondary. Also I have a check for lag. With this, we are concluding this training session. Please subscribe to this YouTube channel for more videos and updates. Also, don't forget to like this video.